Greetings to everybody here today for our November issue of the Innovation Speaker Series. Very exciting. Actually, it's October, and I'm just getting ahead of myself. Great way to start. My name is Ashley Anthony, and I am the Education and Engagement Manager for Climate Reality Project and the chair of the Atlantic Canada Climate Network. This series is a partnership, as we're proud to co-present it with the Canadian Environmental Network. Now, we've all come together for this project to showcase cutting edge emergent technologies and their potential to advance climate solutions and create new opportunities. Before I begin, of course, I would like to respectfully recognize and acknowledge the relationship that is the First Nations, Inuit, and Métis, what they have with the land, historic and current across Canada is really important, especially as we are moving forward through with reconciliation. We want to ensure that we are centering that First Nations, Inuit, and Métis across Canada have this relationship to the land that they live on and that all Canadians enjoy. And we want to recognize that this ACCN organization, where I am here in Atlantic Canada in St. John, operates on the traditional unceded territory of the Mi'kmaq, Wolastoqiyik, Passamaquoddy, Penobscot, and Abenaki nations, or what we call the Wabanaki Confederacy, as well as Inuit peoples. Now, this territory here in Atlantic Canada is not covered by treaties of is actually covered by treaties of peace and friendship, which these nations first signed with the British Crown in 1726. So these treaties actually did not deal with the surrender of land and resources, but in fact established what was to be the rules for an ongoing relationship between nations. So it's in this spirit of peace and friendship that I greet you all humbly today. It also reminds us that the 634 different First Nations communities, as well as the 53 Inuit communities and 8 Métis settlements, all have a unique historical, cultural, and spiritual, as well as environmentally sustainable connection to the land that their people and ancestors have inhabited since time immemorial. So at this moment, we encourage all Canadians in our duty to move forward with reconciliation. And of course, all visitors to these beautiful lands that we live on and enjoy to learn about and regularly acknowledge the historic and current relationship that exists between the unceded lands, again, that we live on, we thrive, we cultivate, we enjoy, and we prosper from. And of course, the First Nations, Inuit, and Métis. We also encourage all Canadians to consider, again, how you personally can contribute to Canada's reconciliation with Indigenous peoples. Now, back to the Innovation Speaker Series. Now, this speaker series has been going on for a while now. If you'd like to see some of our previous videos, you can check out our YouTube channel. I can share the link in a moment. And this collaboration aims to foster knowledge exchange amongst diverse stakeholders passionate about addressing climate. And so today we are very honored to welcome Emily Cowin. Emily is incredible. She's an entrepreneur and an engineer. She's a coach. She's based in Shelburne, Nova Scotia, and she's known for her integrative approach to leadership, sustainability, and personal development. So she is a co-founder of Boxing Rock Brewing Company. I know, totally cool. And she's also an experienced project manager with a multidisciplinary background spanning from food and beverage to agriculture, what brings us together today, as well as energy, government, and even software sectors. Guided by her values of integrity, compassion, and leadership, Emily combines these technical and human-centered skills to support individuals and organizations in transforming and resilience building. So through her work as a certified life coach, a yoga teacher, a facilitator, she also helps entrepreneurs align their professional and their personal lives, of course, navigating stress, burnout, and the complex decision making with purpose and clarity. And of course, this reflects on her deep commitment to community care and reimagining modern work in ways that honor both people and planet. What brings us here today is Emily's work with 46 AG and the 360 rain, an innovative approach at delivering bands of water directly to the base of a plant. 360 rain provides advantages over traditional irrigation systems that we're very excited to learn more about. And of course, this automated system can save time and water in essential farming practices. So with that, so much gratitude for everybody joining us today. And I will pass it over to Emily.
Thank you so much, Ashley. I am going to hire you to write every bio I ever have to write for the rest of my life. That was great. Um, yeah, and thanks for inviting me here today. I'm actually going to start today um, by just telling you how I got to be watering potatoes. As you asked, it is a little bit of a divergence from my previous lives that I wanted to tell you just a little bit more about for context. I want to start by saying that I am not an expert in agriculture. I'm actually fairly new to this. The only reason I have anything to do with agriculture is my partner Craig has been in agriculture for decades, and so I'm still learning. And I'm going to talk about irrigation and I'm going to talk about potatoes a little bit, but I am not the expert in these departments. What I do have a lot of experience in is taking new systems and processes and ways of doing things and ways of thinking about the world, and implementing them in the real world. I'm going to tell you a little bit about my background for context. I will say that this picture is not me. It's what Canva AI thinks I look like. Um, I uh, I told it I own a brewery and wear many hats. So there you go. I am an engineer by trade, as Ashley mentioned, and after moving to Nova Scotia, I worked for many years in local government, and I did a lot of work around sustainability and climate change planning for the municipality of Shelburne, where I still live. And what I heard when I worked with community there is that they didn't so much need sustainability planning, they more needed jobs. They needed people to come to our community and start businesses. And so, um, as an illustration of the kind of person I am, I went, oh, okay, well, I'll do that instead then. And so I opened a brewery in Shelburne, that's Boxing Rock, and that was 13 years ago. Um, I I from that experience have learned firsthand how hard it is to run a business that's a small family business that's values led in today's economy and environment. It's quite a challenge. A couple of years ago, there was a massive wildfire just outside of Shelburne, at which point I realized that it was time for me to come back to uh, climate change and sustainability work. And so I do work with a nonprofit in Halifax called How We Thrive. And in fact, truth be told, that's how I met Ashley in the first place, and was invited to come and talk about watering potatoes because I had a meeting with Ashley from a potato field this summer. And so she asked me what I was doing in a potato field, and I explained, and so here we are. So 46 Ag is an agricultural technology company that we started last year to bring this technology to Atlantic Canada. Um, I also spend part of my time working at the Atlantic Infrastructure Management Network doing risk assessment, particularly related to climate change. And when I look at our food system, which often comes up when we talk about risk assessment and climate change, there are a lot of vulnerabilities in our food system. And so, in working in agriculture, and particularly working in helping farmers adopt new irrigation technology, is part of how I'm doing my small part to address that risk. So I also wanted to tell you a little bit about the history of 360 Rain and what was the inspiration behind it. So this is not technology that we invented. This is technology that was developed in the United States. The development started about 8 years ago. There's a company there called 360 Yield Center, which was founded by an incredibly intelligent man named Greg Sauter. Greg Sauter was the original founder of a company called Precision Planting in the United States, which he sold. I think he sold it to Monsanto in the first place several years ago. And after having sold Precision Planting, he wasn't done with developing technology. Greg is a farmer, and he develops technology for farmers as a farmer. And so he actually founded 360 Yield Center as a nitrogen management company, developing many different types of products to help farmers, uh, increase their yields. And he's also a seed corn producer. And so one year he was growing his seed corn. And again, like I am not an agriculture expert, so if I get this wrong, someone can correct me later. But in order to grow seed corn, you need male plants and female plants, and you plant them at slightly different times. And there was a drought that happened in between the planting of the male and the female plants. And he realized that he was going to lose his seed corn crop if he didn't figure out a way to water the corn, and he had to water the corn, while it was growing. The some of the plants, the ones that were planted first, were quite large. And so he got this idea. He thought, well, I'll take my sprayer, and 360 Yield Center has this technology called Y drop technology that doses nitrogen sort of to the base of the plant. He said, I'll take my sprayer, I'll use the Y drop hoses, I'll fill it up with water, and I'll spread water on the corn. And that's what he did, and he saved his crop. Now, that of course got him thinking, wait a minute, the applying water to a crop at any time is always helpful. Like, you can always make things better for any crop by being able to control when it gets water. And so he spent the next 8 years developing the 360 Rain system, which is an autonomous irrigation system that reels and unreels about 3,000 feet of hose as it crawls around in a cornfield, originally as it was developed for, applying water, but also applying liquid manure and other nutrients as it goes. So this product took him about 8 years to develop. The first machines were deployed in the US in 2023, and we deployed the first machine in Atlantic Canada here in PEI this spring, which was also the first in the world for potatoes. So the cool thing that we did was take this technology that was originally developed for corn and soybeans and adapt it to work with potatoes. There were a number of things we had to do, and also a lot we had to learn about how potatoes and water interact and what the relationship is there. And this is what I'm here to tell you more about. So, uh, the whoops, wow, that's not what I wanted to happen. Let me try that again. Okay, here we go. So I also want to make clear, like I do a lot of work in climate change. I am new to agriculture, and I'm not necessarily industrial agriculture's biggest fan. I don't know that it's the best way for us to be growing our food. In an ideal world, we could flip a switch and all of our food would be switched over to sustainable permaculture practices, or some other way of doing things. But the reality is that this is how our food is produced right now. This is how the food system works. And um, if if we want to continue to eat, but we want to continue to adapt our food system to climate change, we need to do that one step at a time. And food security is going to be a huge risk in the coming years, especially as our climate changes and as our crops are responding to these changes, as we saw in PEI this year and all across Atlantic Canada with the drought. Um, we're not exactly ready for these kinds of changes. And so what attracted me to this technology is that not only does it allow us to adapt our practices to the changing climate by applying water to the crops exactly where and when they need it, but it also gives options to improve soil health through the direct application of nutrients. And for other crops, not potatoes, but for things like corn and soybeans, we can apply liquid manure directly to the crops in season, which dramatically impacts soil health without the use of synthetic fertilizer. So that's one reason. I think this is probably the best way to apply water to crops, because we can do it precisely. Every single plant gets the same amount of water, and we can do it in a way that really is efficient with growers' time and with the water. But secondly, when I was first introduced to the agriculture industry, when I first started, visiting farms with my partner and his other businesses, I immediately saw the challenges that farmers face, and I recognized them as the same challenges that I had faced as an entrepreneur in the brewery. They Farmers didn't necessarily choose industrial agriculture either in most cases. It's just how the industry has evolved, and they've had to come along. And I can relate to that. I could have a whole other hour-long conversation about the beer industry and how packaging has evolved in the beer industry. I was an advocate for many years of the reusable beer bottle, which I still swear is the best packaging for beer. Um, but consumers wouldn't buy them, and so I was faced with the choice at Boxing Rock. We could either buy a canning line or go out of business, and so we now package our beer in aluminum and plastic, even though we know that glass was the most sustainable choice. And so I saw what farmers were facing, and I saw how these small businesses, family farms that have been operating for generations based on their values, um, were really suffering by the same types of challenges that we had faced in the brewing business, challenges around labor, around rising costs, and around changing conditions that they couldn't control, things like the climate. So anything I can do to help farmers is something that I'm committed to doing. And having spent most of this past summer on PEI during a drought, I can tell you that irrigation is probably the most stressful part of growing potatoes, or any other crop, probably. One grower told us over the summer, once you get behind on the water, you run all summer and you never catch up. These growers are watering their crops 24 hours a day, 7 days a week, jumping from field to field, setting up equipment, and running to the next field to shut it down and move it. It's very intense and it's very stressful. And so this type of automation really can reduce that level of stress. So let's talk about traditional irrigation methods for a minute. Traditional irrigation there are many different ways to do it. I've got a few pictures on the slide here. Again, I am not an irrigation expert, but from what I've seen, other irrigation methods can be quite labor intensive and stressful. So where you're setting up equipment, you're letting it run for a little while, and you're coming back and moving it to the next place. It can also be very inefficient. It's very difficult to apply the same amount of water to every plant when you're shooting it across the fields with a giant hose, and the wind is blowing. It's uncontrolled. The water tends to be not evenly applied, and there's a lot of loss of water as it blows around. The other challenge with traditional irrigation methods, if we want to talk about pivot irrigation for a moment, and you'll see the picture here of the crop circles. That type of irrigation works really well if your fields are square, or rectangular even, but there are not very many perfectly square rectangular fields in PEI or in Atlantic Canada. Um, so irregularly shaped fields, which are very common here, uh, are hard to cover with some of these traditional methods, whereas the 360 rain system is designed to drive around autonomously in the field wherever the potato planter has gone. So if you can plant a potato in a corner of a field, the 360 rain machine can go and water that potato. So 360 rain. This is a picture of, we call her Esmeralda. This is the first 360 rain machine in Atlantic Canada. She arrived in June of 2025. So 360 rain is what's called adaptive irrigation. So it autonomously delivers water, nutrients. It can deliver liquid manure, and really anything you can dissolve in water, it can deliver to the crop across the entire field, whether the field is square or circle or oval or long and skinny, doesn't matter. Whatever shape the field is, it can water it. It has 3,000 feet of 3-inch HDPE hose on a reel that unspools and spools back up as it crawls around the field. And when I say crawl, I mean crawl. Its top speed is 8 inches a second, and on average this summer it was running at about 4 inches a second in the field here in PEI. So essentially, what we're doing with this technology is delivering the right amount of water at the right time in the right spot for these crops. So water is almost always the right thing to do. As I mentioned earlier, in most cases, watering a crop is always going to help it. In this case, we can be very precise about when and where we water the crop, and we can be sure we're applying the water directly to each plant. So this is a picture of a 360 rain machine reversing through a field of corn. So the machine itself is powered by electric motors. There's one for each one for each wheel, and then one for the reel, and one for the hose dispenser. So the electric motors are run by a 56-volt battery system, which is charged with a 4-cylinder Isuzu diesel engine. It uses very little fuel. It actually only needs to be refilled with fuel once every 25 days. There are, on that big reel that you can see on the top there are 3,000 feet of hose. And so with that 3,000 feet of hose, depending on the water application rate, we can cover up to 200 acres of corn. And in potatoes, it's probably more like 100 acres because their potatoes are a little thirstier. So let's have another video here, I think. There we go. So this one is showing the 360 rain again in a cornfield. It is actually operated through cellular and dedicated RTK networks. So we will survey the field and create a geofence around the entire field so the machine can't leave the field. And then we track the planter through the field as it plants the crop. And so the rain machine will know exactly where each row is, and paths will be created to water the field based on the very precise location of each planter pass. And so it doesn't matter what shape the field is. If the planter is able to travel there, then the rain machine will be able to water. The hose reel uses some advanced sensor systems to lay the hose out as it moves along a backbone path away from the well or hydrant, and then it picks up the hose as it moves back toward the water source. I think I have another video here. So you can see in this footage, you can see the hose is unreeling in between the rows as the machine moves forward through the field, and you can see the water's being applied by the hoses that drop down in between the rows. So the water in a corn application, we apply it directly to the base of the plant. For potatoes, we're actually watering just above the potato hills. This this video will give you a little bit more of a visual of how the 360 rain machine moves through the field. So you can see it's driving along a backbone, and then it will drive down some rows and back up to the backbone. And so it does that throughout the field. Moving through the field without damaging the crops is obviously very important. So the hose dispenser and the technology around how the hose is reeled and unreeled is actually really important. It measures, so the sensors on the dispenser measure the speed of the machine on the ground, as well as how fast the hose is spooling and unspooling, and the turn radius. And so it's constantly doing a bunch of math to figure out how to let the hose out and what angle to dispense the hose at. And so this was actually probably the cleverest part of this technology. When they developed it, they actually delayed release of the machine to make sure that they got this part exactly right. This is a picture of the app that we use to control the machine. So I mentioned there is like a dedicated GPS and cellular communication system that's included on board the machine, and that allows the rain unit to not only navigate itself autonomously through the fields, following the predetermined paths that we've set for it, but the GPS receiver is constantly monitoring the position of the rain machine relative to a base station, which is located in the field. So it is extremely accurate. One of the things, honestly, that we were nervous about in applying this technology to potatoes was to ensure that the wheels would stay within the potato hills. There's only a few inches to spare for the wheels to drive in between those potato hills. But we found that this navigation system on the rain unit was actually incredibly accurate to probably within a half an inch. Uh, the uh, the cellular communication on the Rain machine allows us to talk via the 360 Rain app to the machine, so we can be really anywhere in the world. And with my iPhone, I can stop and start the machine. I can tell it to go on a different path. And we can also access three cameras to look at the hose reel, the front wheel of the machine, and also out the back. So we can see where the hose is laying on the ground. You can see on the screenshots here, we had a couple of different fields. We used the rain machine in this year, and you can see through the app exactly where in the field the machine is, and you can redirect it to another path at any point. So at 46 Ag, Craig and I are really conscious about who we're working with because this is new technology. And I'm sure many of you have seen this technology adoption life cycle curve before. We're working with the innovators and the early adopters, and that's not everyone, and we know that. To make new technology work in new applications, part of what we're doing is experimenting and learning as we go. It's uncomfortable, and it can be a little chaotic, but the rewards are significant. And that's part of why I particularly wanted to get involved with this project is that as with much of the climate change adaptation world, there's a lot of technology out there that's already been developed, that already exists. The challenges are in adopting it. The challenges are in getting over the barriers in an accelerated manner. And agriculture is no different than any other industry. I know within the beer industry, we're pretty slow at adopting new things. And I've been asked in the brewery, why do you do it like that? And I have been guilty of saying, because that's just how we do it. And so change is hard. It takes time, and it takes a lot of patience and willingness to learn. We could see the potential of this technology to make water use more efficient, but I think almost more importantly, to save time for growers and to improve their quality of life during the growing season, especially when the rain isn't coming when we expect it to. We perhaps could have gone out and invented something new ourselves instead of bringing in this technology. But this is a great idea and this is incredible technology. And so we decided the best thing for us to do was to bring this in and make it work in potatoes and then see what other problems we could help growers solve. These are just some pictures of our hardworking team putting together Esmeralda in the first place. So when the machine arrived in PEI this summer, we had to make some modifications to ensure it would work with potatoes. And so we had the manufacturer make the legs slightly longer so that we had additional space underneath the hose reel, so the reel would clear the potato plants. When they had developed this and applied it originally to corn, the hose reel actually is made to be quite narrow, so it will fit in between the corn plants. That's not really an option with potato plants because they canopy over in between the hills, and so we needed to lift the reel up so that it would clear the potato plants. And we needed to widen the wheel spacing because corn is generally planted at 30-inch row spacing. Potatoes are either 34 or 36-inch rows. So we had to make those changes to the height and to the wheel spacing in order to ensure that the machine would clear the potato plants. Some of the other things that we learned, and I've talked about this a bit already, is that uh, the GPS tracking is extremely accurate. And so there were no changes that we had to make to how the machine was controlled in the potato field. It was actually perfect in terms of running between the potato hills. What we did have to change, though, is the plumbing. So when it was applied in a cornfield, they were essentially using drops to allow the water to dribble on right next to the corn plants. So there was no pressure restriction in the line. In order to water from above, which is what we wanted to do with the potatoes, we had to put nozzles on the end of the drops to create kind of like a shower head effect to dispense the water over top of the potato plants. This created back pressure in the system, and so we had to make a bunch of plumbing changes in order to allow for that pressure throughout the boom. We also discovered, and this was actually quite interesting, the field that we applied this technology on in the first place had actually been irrigated for probably 40 years. So this particular grower had been irrigating potatoes for many, many years. And so the infrastructure was actually um, pretty rudimentary, like pipes in the ground, single valves. There wasn't a lot of control within the water system. And so what we've discovered is that being able to control the pump and the pressure in the system is key to being able to control the rain machine the way we want to. The other things that we're working on for 2026 is a wider boom. So one of the things that's really important to growers is to minimize the traffic through the fields during the growing season because driving anything through the field creates compaction in the soil and can reduce yield. And so what we'd like to do is be able to follow the sprayer path wherever we can. But in order to do that, we need to widen the boom for the 360 rain machine. So we're working on that as well. It was quite windy at times this summer in PEI. In addition to there being absolutely no rain, there was quite a lot of wind. And so ensuring that we have the right spray patterns on the water to match the wind conditions is really important to ensuring that water efficiency, ensuring the water reaches the plants and isn't carried away with the wind or evaporated. So over the course of this summer, we just some statistics in terms of what we did. We irrigated for about 1,100 hours, which was probably more than we ever imagined we would, and applied about 7 inches of water on the 66 acres of potatoes we were irrigating. The machine was on about 70% of the time between July 1st and September 22nd when we stopped irrigating. The downtime on the machine was almost all related to infrastructure issues. So the water infrastructure that we were using to supply the rain machine with water was being shared amongst multiple farms, and there were multiple infrastructure issues, leaks in pipes or pump problems, et cetera, that affected our ability to run the machine. Over the course of the summer, we used about 2,650 liters of fuel, so it costs about $4 an hour to run the thing, which is not very much. It just sips the diesel to charge those electric motors. And there's very little maintenance required except grease during the season. So um, there were there were days when the grower just didn't even see the machine for, most of a week because it was just autonomously running by itself in a field applying water. And that certainly saved him a lot of time and a lot of stress. And this is, I guess, what we're working on next, and what I want to talk a little bit more about, which is that what we've discovered over the course of our experience this summer is that a lot of the challenge with irrigation is about measurement and control. And so as we continue to improve our solution for watering potatoes, we'll start to integrate other new technologies. And so there are a couple of screenshots here um, from a company called Aquaspy, which manufactures probes that you can stick into the soil that will measure moisture content in the soil at various depths. And this is where we get to making irrigation more efficient and more effective. So um, we we discovered partway through the season that we didn't have a good way of measuring whether the potatoes had enough water. We knew how much water we thought we should put on, but we didn't have a way to measure whether the plants were actually receiving that water. And that's what led us to Aquaspy and their technology. And so we brought in 3 probes, we installed them in the field, and we started to monitor the moisture content at various depths within the field. And we were able to see very clearly, when the irrigation was happening, but we were also able to see very clearly when the plants were taking up moisture from the soil, which, as it turns out, mostly happens at night. Uh, there's a sort of an ideal band for plant growth, an ideal amount of moisture available to the plant. And so as we move forward with this technology in the coming years, we will hopefully be controlling how much water we apply by measuring the moisture content in the soil in every field. So, from what we've seen in potatoes and PEI, the growers are really, really good at getting water to the fields. Um, they will do whatever it takes to get the water to the field. Once the water's in the field, I think this technology will help us make sure it gets to every plant at the right amount at the right time. And so we're also working with some other ideas for new technology and how to incorporate that. There are a number of wireless pressure and flow sensors that we can integrate so that we know exactly where the water is ending up. And we're hoping to get better at adapting the application of the water to the weather conditions, things like wind and temperature, uh, so that we can, again, optimize how the water is applied and make sure that we're being as efficient as possible. So we know that water is a resource that over the coming years will become more and more scarce, and I think more and more restricted and controlled. And so technology like this ensures that we can track how we're using the water, but also that we can be as efficient as possible in applying water to the crops. Okay, I guess that's all I had to say about that. But I'm sure I missed some things. So, Ashley, do you have questions?
You did an amazing job, Emily. Thank you so much. I learned so much more about just even potatoes than I thought that I ever would know in my life. First, I want to open it up to the audience. If anybody has a question, feel free to unmute or to drop the question in the chat. We're always very excited for audience questions. I have a couple of questions for you that I wrote down during your presentation. One of them you talked about if you plant a potato there, we'll be able to go and water it. I'm wondering like the viability on like flat land versus maybe some more rugged terrain. Like I'm in New Brunswick, all the farmer fields around here are hardly flat. I went apple picking a couple weeks ago on a hill. And so I'm wondering if that more rugged terrain, like how does it fare?
Yeah, great question. And I'm probably not going to be able to quote the exact numbers, but we can go look them up on the 360 Rain website. But it does like it is able to come up and down hills, and it does actually one of the sensors it has. So if you can imagine, it's got the booms out like this, and when it's on rough terrain, it can, waggle around a little bit, and it does measure that, and it does actually stop itself if it thinks it's unstable. It will stop itself and throw an alarm and say, I'm not sure, I might be tipping a little bit too much. And so you can go on the cameras and check it out. But it does have the ability to get up and down some topography, but there is a limit, of course. But yeah, some up and down is good. And one of the fields we were in this summer actually did have a pretty significant sort of slope to it in places, and it did all right. Yeah.
And the lines that you illustrated were very straight. Do they work? I imagine you can map in
Mhm.
all different curves and settings.
You sure can. Yeah. It does have a limited turn radius because of how it's laying the hose down. So you can imagine, an HDPE hose can only bend, at a given radius, and we don't want to get anywhere near kinking that hose. So it does have to take some turns a little bit wide. But yeah, it can certainly move through different directions. I think most fields, if they can be planted in straight lines, usually are, but there are fields that do have curves and different directions in them, and so it's got three wheels, and it can turn, fairly sharply with those. So yeah.
Brilliant. I'm wondering about its capacity as well. Like, what are the smallest fields that you could have this, that it would be feasible to have it
Mhm.
versus like maybe some of the larger applications? If you had multiple fields, would you have
Mhm.
to get multiple machines or would
Mhm.
one machine be able to kind of do it all?
Another great question. I think the smallest field is really going to be limited by cost. Like it's a fairly significant investment. So you're going to want to irrigate the largest area you can with it. For potatoes, we would say if the field is kind of like one uh, contiguous sort of piece of property, we can do up to about 100 acres. If we have to move it, so in this case, we irrigated two fields that were not quite right next door to each other, but where there were three fields over basically. So we would irrigate one field, we would shut the machine down after about 4 days, and then we actually mapped a path for it to drive itself over to the other field because it took about 45 minutes because it's really slow. So we would unplug it from the hydrant and say, go to the other field, and it would drive itself over to the other field. And then we would plug it back into the hydrant and let it go on the other field. So if you have to move it between fields, it the I guess the real answer to your question is the amount of the area that it can irrigate is very dependent on how much water you need to apply. So in a year where it rains, you could probably irrigate a larger area than in a year where you get no rain, because you just don't need to water it as often. So the thing can run 24 hours a day, 7 days a week. Um, and if you want to, in this case, we wanted the capacity to apply an inch a week to the potatoes, which means, we can do 80 to 100 acres depending on how much you have to move it. For corn, they only usually want half an inch a week, and so they can do 200 acres. If there's a crop that wants a quarter of an inch a week, then you could do 400 acres. And if it rains a lot and you only need to irrigate it, once a month instead of once a week, then you could do more. But um, there are, it's not the easiest thing to move. It's not like a tractor. We can't drive it down the street because it only goes 8 inches a second. Um, so it's really its capacity is limited really only by how much water you want to apply, how often.
Yeah, and so it's safe to say the duration per field depends on the amount of irrigation needed on that field as well.
Yeah, exactly. Yeah.
We have a question in the chat. What is the approximate cost of something like the 360?
Ooh, that's a great question. I would like to ask you to send me an email and I will let you know.
And
Because
that's
it
Emily
depends.
at
It depends. Yeah,
46ag.ca,
yeah,
everyone.
yeah. So, um, yeah, hundreds of thousands of dollars, but it depends on how much infrastructure, is required in addition to the machine. So, yeah.
And you said that there's electric motors, but that they run through like a diesel generator that kind of like recharges them. Is there a future version that they have envisioned that's completely electric, or is that kind of the way that it is?
Yeah, I mean, I think the possibility is there for it to be solar powered for example. I don't know where that is in the development cycle. They've designed it to be as fuel efficient as possible, and the diesel engine will come on to charge the batteries, automatically when they need to be charged. Um, the and I think I'm just guessing here, but I believe that they chose that to ensure that it would run all the time, and there was never any question that the batteries would be charged, and then just tried to make it as efficient as possible. So
Especially because, as you said, a lot of the absorption of the irrigation happens overnight. And I
exactly.
imagine if you're working your fields or like doing something during the day, irrigating overnight can be a lot easier. Nobody wants to get up in the middle of the night and have to figure out why it's not working. Uh,
Exactly.
my next question is like a lot of the issues that people have around crops like this is like nitrogen and runoffs. Does this
Mm.
reduce the amount of runoffs? Like, is there any type of investigation around that?
Uh, that's a great question. I think in theory it could, because again, we're looking at applying the water as close to the plant as we can, so that water gets absorbed by the soil and doesn't run off. And we're looking at applying the water at exactly the right rate. So one of the things that we did this summer was rather than apply. Like the grower wanted us to apply an inch of water a week to these fields. And rather than apply that in one pass, which would have meant we drove the machine at 2 inches a second, went really slow and put a lot of water on all at once. We tried that and we found that there was actually, quite a lot of water that was running off in between the hills. And so what we did instead was we applied half an inch at a time, but did it twice in that week. So we went faster, um, and applied less water, but did it twice. So by the time we got back to the beginning again, it had been 48 hours and that water had soaked in. So, you with this type of technology, you have the opportunity because it's autonomous. You have that opportunity. You can slow it down. You can speed it up. You're not limited by working hours and humans need to sleep and all of that kind of thing. Where it's quite flexible and adaptive to the needs. So that's one thing. And I guess the second thing around nitrogen and runoff is not in potatoes, but in other crops like corn. This technology can be used to apply liquid manure to crops, which can actually be much more beneficial than applying synthetic fertilizers in other ways. And we can also use it to apply liquid nitrogen, th along with the water. And again, so that can be absorbed directly into the soil very efficiently. So um, because we're able to move through the entire field, no matter what the shape of the field, and apply whether it's water, manure, nutrients, whatever it is, as close to the plant as we can, that will, I think, have the potential for sure to minimize that runoff.
And my assumption is the increased frequency in the irrigation helps reduce like the hydrophobic tendency of the soil driving out, which then reduces the runoff because if it's being absorbed, it's not just pooling on the top and
That's
running
right.
away.
Yeah, absolutely. Yeah. You sound like an irrigation expert.
I have houseplants. You go too long without watering them, they are not happy. If anybody else has a question, please feel free again to unmute yourself or drop your question in the chat. I have always so many questions. My next question is actually about like compaction in the soil. Does it take the same route every time, or do you alternate different rows to avoid that compaction?
No, we take the same route every time because uh, it's quite heavy when it's full of water. I think 26,000 pounds or something like that. So compaction is going to happen no matter what the
So you
first
keep
time
it
you
to
drive
one
it.
spot
So we
then.
keep it to one spot. Yeah, we try to minimize that compaction, and that's really the driver behind trying to make the booms on these machines match the sprayer booms exactly, and those tend to be quite wide, 90, 100, 120 feet. So that's a little bit experimental, but if we can match the sprayer boom widths, then we can keep to the sprayer tracks on the rear tires. And so then the only new track we would be introducing would be for the front tire.
Brilliant. And my last and final question for today, anyways, is the future crop application. Now, outside of corn and soy and potato, has there
Mm.
been any investigation on other relative crops that could benefit from something like this?
Yeah, and this is not my own direct experience, but having heard through the 360 Rain network, I know that they're using it for beets in South America. Um, and uh, and there's also a lot of work being done in, applying other byproducts. So I believe the beets in South America are sugar beets, and so then they're being used to produce sugar. And then there's a whole bunch of organic material that can then be used as a nutrient and reapplied through to the next crop, essentially through the rain machine. Um, yeah, so there's all kinds of possibilities, right? Now, uh, um, once you have it out there and working, there's all kinds of things that become possible. So beets for sure, but like really, any market crop like potatoes, it would work the same way. I think, carrots or turnips or whatever it might be. So
Ideally, if you had the same uniform conditions, like the same row widths and everything like
that's
that,
right,
you'd be able to expand the application.
for sure. Yeah.
It's brilliant. Well, that's the end of my questioning. Does anybody else have any questions or comments? Well, wonderful. Emily, thank you so much for your time today. I've learned so much, and I assume that everybody else has as well. We appreciate it and hold so much gratitude for you sharing your wisdom. And we hope to see some more interesting updates from the work that you do in the future. Thank you so much.
Yeah, thanks for having me, Ashley. I appreciate it.